My name is Lambrecht. I have a Master of Science in Pathology. Does anybody have any idea what pathologists do? You ever seen things where the doctors, where they're examining the body and trying to figure out why the person died? That's what a pathologist does, and that's what my master's training was in. And I actually worked on autopsies and a number of different kinds of research. I worked in Wisconsin, I worked on bio materials. So we worked on things. I actually got to meet the person who did put in the first artificial heart. I was working with chemical engineers, and they were trying to make materials that could go into bodies, like if you have to have a heart valve replacement or a vessel replacement, something that would be compatible with the blood. And I worked on alcohol research, and that's really, really important if you think about all of the awful things that happen to your body with excess alcohol. So we were trying to work on how you could prevent that. Not drinking as much probably would be a good part of it, but also what to do when the liver was damaged. And then my final job, which I just retired from just about a year ago, was here in Worcester, Mass, at the University of Massachusetts, and I managed a lab where we studied pediatric AIDS. And we also studied something called EBV, which is the virus that is responsible for mononucleosis. Kissing disease, have you ever heard of that one? So we were studying those viruses, and again, how to improve them. Actually, within our lab, we were the first lab that came up with the way to prevent transmission of HIV from moms to babies. And that's used internationally now for preventing HIV. When I first started in that lab, approximately at the time, every mom that was HIV positive or had AIDS, their babies, 40 to 50% of the babies would get the disease. Right now, that percent of, if your mom is positive and has HIV, it's down to less than 1% of the babies get HIV. So it was really, really important work. And in fact, with prevention and the medical treatments, a person can live now pretty much a full life. When I first started, the lifespan was about 4 years, and people would die of AIDS. So a lot of this research that I have done has been involved with some really important things, and I always have loved science. Now I work part-time for a group called Science from Scientists, and we go into schools similar to this type of thing. We do little hands-on experiments, mostly to show kids that science is fun. So I hope you guys have fun today. And today what we're going to learn about, and you've got your papers in front of you, are the states of matter. There are 3 states of matter. So can anybody tell me what those are? Sure.
Liquid, solid, and gas.
Liquid, solid, gas. So liquids move freely about, but they have some form. Gases move freely about, like the air that we're breathing, but they just will move about, take up whatever space there is, and they're very, very random. Solids have structure, okay? Those are the 3 things. So we're going to actually today, with dry ice, we're going to see these 3 states of matter. Does anybody know what dry ice is? Yep?
It's ice that is frozen carbon.
Yeah, it's carbon dioxide that has been frozen. And you know what's different about dry ice versus solid ice, regular ice?
Dry ice turns directly into a gas.
It goes directly to a gas. We're going to see that today, sublimation. But the other thing about it is that it's much, much colder than regular ice. You don't want to touch it with your bare hands. What does this stuff on top look like? What does it remind you of? Yeah.
Fog.
Fog, yeah, it's exactly what it is. Now, do you think that's the gas from the carbon dioxide that's making it look like that? You'd think it would be, but actually it's not. It's actually from the water. So the water is actually going directly from a liquid to a gas. And this is what happens when there's a really, just the right conditions and you have a really foggy night. So interestingly enough, this fog is actually heavier than air, and you can try this. You don't want to pour it too far. You can actually pour it into your hand and collect it. So play with it a bit, look at it a bit, think about the different things that are going on. before we go on to the next thing. So you're still having sublimation going on. You're also having the liquid going to a gas, so you're having vaporization. Does anybody see little drops of water on the outside of their cup? That's actually going from gas, from the air, that's the water that's in the air, to a liquid on the side. Oh, I thought you were drinking the dry ice there for a minute. It won't hurt you. It's just like, it's like carbonating a beverage, you know. There's nothing really dangerous about carbon dioxide. Carbon monoxide is bad. Carbon dioxide is bad when there's too much of it. When you think about so much given off by fossil fuel burning, either power plants or cars, that gets into our air and doesn't really go away enough. That's what leads to, believe it or not, global warming, which scientists do believe in. So carbon dioxide as a gas is not dangerous. We breathe it out every day. When we breathe in oxygen, we breathe out carbon dioxide. So you see a liquid, and is any of the liquid changed to anything? I think, we saw the liquid to gas. That was the vapor or the fog. If you look at, as it tends to go down a little bit, does anybody notice that their dry ice looks a little white around it now? What do you think that process is? This is more like you're going to see in your refrigerator. Somebody see that white around it? That's actually just regular ice. What's happened is the water has frozen around the dry ice. So we also got to see liquid go to a solid. It's actually forming ice crystals around the side of the dry ice. It's the same thing. How about in the morning? Have you ever gotten up, go outside, and you see dew on the grass? Same process. So most of these are things that you're going to see every day. So the next thing we're going to do, you each have a test tube, and you can hold on to the test tube. It's not going to hurt you. It is cold. I mean, the bottom part is cold, but it won't burn you. So now with your test tube, I'm going to give you a balloon. You can put the balloon on top of your test tube. Okay, so what's happening in the tube right now? It's the one where it's going directly from that solid to a gas. I know we're seeing that one. Does anybody remember what that's called? That's sublimation. It's still going directly from a solid to a gas. What's happening when you put the balloon on? Actually, sometimes if you warm it up a little bit with your hand, it will speed that up. So it's carbon dioxide is being given off by the dry ice. It's expanding the balloon. Eventually, you can actually pop it off the top if you get enough gas going, or if the balloons are big enough. And if you don't, if it's not doing too much, I can give you another bit of dry ice. Yeah, don't point it towards your neighbor or your parent. Oh, nobody's popped off yet, huh? What's that?
So it's fine if I'm not holding this?
Yeah, it is. It's not going to go hard enough to hurt anybody. Has anybody ever done rocket balloons with using baking soda and vinegar? It's the same thing. You give off a gas. Anytime you have a gas in an enclosed area and you don't have anywhere for it to go, you can create quite a bit of pressure by having the having the gas go into some kind of a container. In this case, we're using the balloons. That one looks pretty, I'm amazed it's blown up that much. It will make a really loud noise if it actually pops. Okay, so wow, now I can see everybody's, I can see lots more gas coming off, lots more bubbling going on. Put a little in mine too. It's fun, play with it. That's what it's for. I'm going to give you a little more water too, that charges it up. And then I'm going to go on. Is that the wrong thing? I thought we started late, so I thought this would take a lot longer than it did, but I had plenty of time. Did I give you a little extra water? Okay, so what grades do we have here? You okay?
I don't think my balloon's expanding anymore.
It could be that you've kind of run out of production from your dry ice.
I don't want to just slide it off.
Yeah, yeah. That's the next thing is now we have to figure out how to get all these balloons off of the test tubes. Yeah. Okay, gas. What kind of gas? It's coming from the carbon dioxide coming from the dry ice. So there's carbon dioxide coming off. What's that fog? Anybody remember what that was? That was the liquid. It's actually the water going to a gas. Anybody remember? Yep. Vaporization, right? So we got those two. We will see the same thing where we saw the ice freezing around the dry ice. We saw actually regular ice, so we saw freezing. We saw water condensation on the outside, and now my hands are all really soapy. We'll see if I can get this going. I think I need a little more soap. And it might be the people that are in the back, you might want to come up and stand up here towards the front, because this is a lot of fun to see.
It's getting really good.
So you can see a lot of gas is being given off. Well, I hope I can get this to work for you. It's going to work. I can see it. And the only thing is, don't blow on it. So have a little patience. Sometimes it takes me a couple of tries. I'll do it a couple of times if we... Is anybody close enough to see there's a bubble forming? Can you see the color forming on the top of the bowl? You can come closer if you want. Too much is going to happen for a little bit. So we're seeing all the states of matter right before our eyes. Can you see the bubble? Now watch it. So what's happening?
The bubble is expanding because of the gas pushing on it.
Right.
Trying to expand it, so it's getting larger.
Bigger and bigger. Eventually it will burst. We'll see how good of a bubble I made. Why does a bubble, does anybody know any surface tension? That was something we did a lot when we were in biomaterials. There's actually the surface tension of the bubble itself, the soap in the bubble, and you saw I put a lot of soap on it, that makes that bubble strong enough to hold that gas. It's just like kind of the same principle as your balloon. How big do you think it'll get? I'm going to back away.
You can see when the dry ice makes the fog, and you can still see it through the bubble.
Yeah.
You can kind of see it.
You can see it's actually escaping a little bit on the edges, isn't it? A little bit of that soapiness. But I'm pretty happy with that. That's a pretty good bubble. You can come closer if you want. You want to come around the back? Around this side? You think it's going to burst?
Hopefully.
Oh, I know it will. I'm surprised it's that strong. I must have had a really, really good, nice, thick soap bubble. I know if anybody breathes hard enough, it will definitely pop on us. But it doesn't have much longer, I don't think. You can even, yeah, you can see the fog bubbling up inside. Can anybody close enough? You can actually see it in there. Oh, okay, look, I could even see a puff going up there. We'll put in a little more dry. There it goes. When it happens, it's really quick. Working with kids is so much fun, very rewarding. And when you see kids get excited about science, it's just, that's great.